Success in calculus depends on your background in algebra, trigonometry, analytic geometry, and functions. So let's review a couple of things before you jump into all of the complexities of calculus. I wouldn't call them complexities. Well, that's if you know functions, but let's go ahead and do some number sets and number systems. So a set can be thought of as any collection of distinct objects considered as a whole. Okay, typically sets are represented using set builder notation and are surrounded by braces. Okay, so now with braces, you know there are the round braces that look like that. You can call them round brackets or even parentheses. These are obviously the square brackets, but none of these are the ones you're going to use to describe a set, right? Using set builder notation, you're going to use the braces or the curly brackets, and they look like this. All right, so an example, let's say the first example, could be a collection of some numbers. You could have, say, A, B, which you don't know the values of A and B, and then you have 1 and 2. All right, so that set is a set containing the values A, B, 1, and 2. You can also name the set, right? So let's say you have set A, S, not A. Let's say S. S for set. All right. To say that any number belongs to this set, you would use the symbol E. It's a weird E. It looks like the euro symbol, but without the second line in the middle. The second dash, that is. And you could say X is a value that belongs to the set S. You could say that this means X is an element, right? This E comes from the word element. X is an element of S. All right, that means X is inside that set. All right. So, but if you have a number that's not in that set, right? Let's say Y. Y is not in S, then you would use the same symbol, but you would cross that out, right? So Y is not an element of S. All right. So now, if you determine S as, let's say S is the set of A, B, and C, okay, you have all the things we've mentioned so far. You have the capital letter to determine that set. That set is going to be equal to, here are the brace brackets and all the values inside. But if D is not in there, okay, then you would say D is not in S, whereas A is in S. All right, hopefully that makes sense. That's not too bad. All right. Now, when you're talking about different kinds of sets, let's say you have 2 sets and they have a bunch of values in them, and you want to look at which values in those 2 sets are exactly the same. Then you would talk about the intersection, right? The intersection between 2 sets. Let's say you have sets S and T, right? So that would be denoted as such, right? So this is how you would write it, intersection, right? Let's say you have S and T, you would use this symbol. Okay, you're probably thinking, well, that looks like an upside down U. Where does it come from? Well, it actually comes from the other part of dealing with questions that pertain to the values in a set. That is the intersection, right? This is dealing with the values that are common in S and T, right? Values that they share. The union, though, between 2 sets, and you guessed it right, those are going to be the collection of all the elements. That's the collection of all the elements that belong to either S or T, right? So you're just mashing all of the elements together. You're putting them together. So that is where the upside down U comes from. It comes from the word union. So you would have S union T. All right. So that U comes from union, and the intersection is just flipping it over. All right. And if you look at the example above for S, let's do another example. Let's say S is still the same. You have A, B, and C. And let's say T is B and D. All right, what would be the intersection of S and T? All right, go ahead and take a second, write down in the comments what would be the intersection of S and T. Those are all the values that S and T have in common. Okay, you should have written it by now. All right, those are going to be, well, there's, if you look at this set, it's actually only one value. That's B. All right, and what is the union of S and T? And like I said before, it's just all the values matched up together. So you would have the union of S and T as A, B, C, and D. Okay, wait, hold on a second. You said Josue, you said that the union was going to be all the values matched up together. Why do you have 4 elements in S union T, whereas if you count all of them in total, there were 5? Well, yeah, but B was shared between S and T, so you would just write one B, which is right here. You wouldn't write A, comma B, right? That's just a bit redundant.